All right. So you want to spend some time on trigonometry, right? You don't love it, right? Yeah. Right. So we're going to spend some time on tricks. We'll take a look at few of the functions that we would have done already, right? So we're going to take a look at the sine function. We're going to take a look at the cos function and tan function, right? So we're going to spend some time on these three. You all remember what the general shape looks like for each one? Yeah. Right, the sine graph will start at 0. Cos graph starts at 1. Nice. And the tan has asymptotes, right? Nice. What's the shape though? What's the shape? All right. So let's go a little more in depth into each one, and then we look at sketching different versions of it, right? So kind of showing some of the graphs to us. All right, so we're looking at the sine graph, right? So the first thing we're looking at is y is equal to online. You're here, right? Online over there. Yeah. Yes. All right. Nice. Right. So, in your sine graph, right? There's specific values that you should know, right? I am not doing degrees anymore, right? I'm just focusing on radians. Okay. Right. Actually, you all remember this, right? Yeah. Pi is how much degrees? Pi is 180, right? So pi on 2 is how much? 90. 90 and so on, right? That's okay. I remember that. All right. So we're going to focus on the sine graph. Right? We're focusing on specific values. We're focusing on pi on 2. We're focusing on pi, 3 pi on 2, and then 2 pi. Okay? Anybody remember the largest possible value sine could be? What's the largest possible value sine could be? And the minimum value is? Right? And the minimum value is minus. Right? So the largest value is 1, and the smallest value is minus 1. No, I can't believe that. Right? So let's start here. Right? 0, right? Here is 0. Right, sine 0 is what? 1. You use a calculator. Use a calculator now. All right? Right. Sine 0 is right. Do not say about. Find sine of all these values. Stop it and let's get it shape. Find sine of all your values. Yeah, so we need all the values, right? Sine 0 is how much? Sine 0 is 0. Sine pi on 2 is what? 1. Sine pi is? Sine 3 pi on 2 is? And sine 2 pi is 0, right? Right, so that's the shape of the sine graph. Okay, that's the shape of the sine graph. And what's the period of the sine graph? What? The period of a sine graph is 2 pi, right? So the sine graph will begin to repeat itself after this. Not 1 over t, right? A period is 1 over f. Right? I know we have Casios, but we should know these values, right? We should know the values for sine pi on 3, sine pi on 4, sine pi on 6. Sine pi on 3 is how much? Oh yeah, find those fast. You need to know those values, right? You need to know those values.
Yes.
Right, so the first one is what? The first value is Darion. What is this? This one. And last one. All right. So we have to know those values, right? Nice. So these are the values that we need to learn for the sine graph, right? But we need to also be able to sketch any form of the sine graph based on these little things, right? So for example, suppose I ask you to find you have to sketch that? You have to learn to sketch that. Okay? So we need to be able to sketch functions at this form. All right? Okay, so we're going into this test now, but before we do that, anybody remember what quadrant sine positive in? No, which one? Sine positive in. Sine positive in the first quadrant and the negative in the. Okay, so we need to remember that, right? Okay, so all of the form 5 stuff that we should know, right? So if I were to split it up into quadrants, Darian, sine positive here, here, negative here, and here.
Yeah.
Okay? So I want to remember those things for sine and thing, right? So we're taking a look now at the general form, right? Online, are you okay? All I just form 5 stuff, right? Esther, okay there? Oh, yeah, so you are Samsung, okay. I'll know with that. All right, Kelsey, are you okay there? Yeah, okay. So good. How do we sketch any form of a trig function, right? Suppose I give you a general form like this, right? Instead of theta using x, right? Marquis. Right? We need to know what each one of these letters represents, so we'll know how to sketch it, right? From the transformations we did, anybody can predict what the C will do? What will the plus C or minus C do to a function? To the function sign. What is that? Yeah. What will the C do to the function sign? Close it. And then shift it up and down. Right? What will the A do? Left and right? Now. It will stretch it. Right? It will stretch it or shrink it, right? And what will the B do? So A will stretch it vertically. B will stretch it horizontally. From a transformation. Right? So A helps you find your amplitude. So in our example here, our amplitude was how much? What was the amplitude here? 1. So here, see that? So the amplitude was 1. Okay. The C gives you the vertical shift. Right? Of course, we know that plus C is upwards. And negative C downward. And the B helps us find period, right? But I'll write it like this. Period is equal, huh? No, C, oh. Negative C, sorry. And the period is 2 pi over whatever B is. All right? So when C is 0, your graph will stay on the 0 line. Okay, now? When B is 1, like our example here, P is 1. When P is 1, the period is 2 pi. Okay with that? Yeah? Also P just a constant. All constants. A, B, and C are constant, but it's showing them what each constant represents. Right? I mean, okay with that? No? Talk to my dad. Talk to my dad. Yeah. So A represents how we stretch it. So for example, if A is 1, the graph looking like this. A is 2, what will happen? It will double, right? Twice as big. If A is a half, what will happen? It will shrink vertically, right? Pardon me? Right. So if you see in our example, C is what? Sin theta. See, can you see? No, so C is 0. So C gives you an idea where the equilibrium line. So here's where it started. So if C is 1, what will happen to the whole graph? It will shift up 1. If C is 4, shift up 4. If C is minus 1, comes down. Right? And the value in front of theta or x tells us what the period is. So in our example, what's the value in front of theta? 1. So the period is 2 pi on 1, which is 2 pi. Right? So let's try a small example. Let's try 3 sine 2 theta. Let's not go too far, right? Minus 2. Try to sketch this. Okay? So I want to show you how we're going to do this, right? All right. Do me a favor, write this, and just sketch this here, and then we're going to do it together. Right? And then we're going to do it together, right? Copy now. Copy now, and we're going to do it together, right? Right? If you're not seeing it starting at 2 and it finishing at -5. Right? Right, we're going to do it together. Victoria. Ready? Yeah, so let's begin. So here's how we can work out, right? We know that the graph shifting downwards. 2. So you normally start in your sketch, you kind of start with this here, right? We can't start with 3 because 3 represents the amplitude, but it doesn't tell us what's the maximum value. So here what I like to start with. I like to start with C, right? And I know that C is -2. So it means now that the new, I call it the equilibrium line, right? This is called the equilibrium line. The new equilibrium line is -2. So that is our equilibrium line.
Also, never really strong with one and like the one that kind of.
Right? So you're shifting it downward.
Yeah.
So your new equilibrium line is -2. Right? So I join that first. Right? The equilibrium line is -2. The equation for it as well. Y is -2 in this case. Right? Next. What do I need to know next? I need to know how far my graph going up. So I need to know what is the maximum value, and I need to know what is the minimum value. Here's how easy that is, right? The maximum value, we know what the amplitude is, right? So the maximum value is the amplitude, which is A, right? Plus the shift, plus C, right? So your maximum value is equal to your A plus C. A is 3 plus C is -2. So our maximum value is 1. That's okay? So your graph going up to 1. Samira? You sure? Right? So the usual thing is starting at 0 and it going up to 1. Everybody okay with that? Any ideas how to get the minimum value? Any ideas how to get the minimum value? Huh?
A minus C.
A minus C. Yeah. No.
Yeah. Yeah.
Think about it. A minus C. So you saying A minus C, right? A is 3 minus minus
A
2, that's 5.
minus C.
A minus.
Right. Oh, wait, no.
Take time, take time.
Yeah, A minus C. Minus A. Minus A. Minus.
So it will be C minus C. So it's C and you minus it whatever here. Right? So C is minus 2 minus 3. So I got minus 5. Okay? So that means that the graph going down to minus 5 and then coming back up. Okay? Now for the part that we tend to forget, watch this here. So we use C and we use A. But we didn't use us yet. B, right? So period is what? Period is 2 pi on B, right? So that's 2 pi over 2. So therefore the period is how much? Everybody okay with that? Period is pi. So it means that this whole cycle took how long? This whole cycle took pi. So I just line in the top here, pi. See that? So this whole cycle is pi, right? And half of the cycle here is pi on 2. Right? So to make it simple, I'm going to sketch theta between 0 and pi. Are you okay with that? So watch it again. Watch it again. The first thing I dealt with C. C told me where the graph will now belong. The equilibrium line, where the graph will now start from. Right? So let's shift the whole graph down to. So the graph now will now start at y is 2. Right? So the graph will no longer start at y is 0, it will start at y is 2. Okay? Then maximum value A plus C. I get 1. So I carry my graph up to 1. And then minimum value C minus A. So I took minus 2 minus 3 and I got minus 5. So I took my graph down to minus 5, bring it back up. We know what the sine graph looks like. This is the sine graph. So we know that's one period. Right? So we can work out one period is 2 pi on B. So we know that this will take time. That's okay? So you notice I didn't put any scale here as yet, because to me, I find it easier to sketch it first and then put the scale. Right? That's okay? So sketch it first and then put in your scale. Right? To make it simpler, I said sketch a graph between 0 and pi. Suppose I said sketch a graph between 0 and 2 pi. What would happen? Wait, what would happen? Suppose I said to sketch a graph between 0 and 2 pi. Nothing will happen. Period is 1 pi, and so what would happen between? Okay, let's do one extra. Okay. Everybody okay with that? Online, are you okay there? Esther, are you okay? Jesse, Isaiah. Vaishnav, Garaj, are you okay? Right, so when it's touching, go with C and then A and then B, right? Online, when I give you one, you can pick up it and send it to me, right? Right, so again, just like when we did transformations, technically all these things are just transformations, right? It's a stretch, a shift, right? And a shrink or horizontal stretch. And okay with that? That's all we're doing, right? So you have to learn the graph. So if I change it to cost, you have to remember the base cost on shipping. All right, let's do one more sign. All right. Do you think that? And give it a minute, say what two when it was there.
But they say,
Yeah, I'm supposed to.
it says I think easy one. Yeah, but you're right.
Ali again, sure. Yeah. Pass it. Yeah, leave it like that. Go ahead. Oh, speed is just
Yeah. Just go ahead and click on that.
Hey, what's going on, right?
What else?
Like, take a pic and send it graph, right? You understand how I got?
Oh, I get you. Oh, we.
Right, then let's check out Jesse online. You can take a pic and send it, right? Let's check it out, Jesse on here. Jesse, yes, Jesse, that looking good boy, Jesse, buddy. Yeah, Jesse, that's it. I asked for between 0 and 2 pi.
Yeah. Yeah, the night and I think that was that.
Like in last one there. Alright, let's see what you got. Any more online? You can take a quick and send it, huh? I'm gonna shop of course. Right, so Jesse, yours good, right? Anybody else send anything online? No. Aliyah, you can take up the send it from my WhatsApp, right? All right, let's see. Let us see. Your shift. Oh, sorry. I'm gonna just do this thing here for you. Right. First thing first, C is equal to 3. So therefore, the new equilibrium line is 3. Remember, equilibrium line is where the graph will start or stop, right? So the equilibrium line is 3. Right? Y is 3. So the graph will start and stop on this line, right? Well, what's the max value? Your max value is 3 plus amplitude, which is 5, which is 8. Minimum value is 3 minus 5 minus 2, right? So we know how the graph behaving. The graph going up to 8, coming back down to minus 2 and coming back 8. Right? Do we need all of that? Let's see. Period. Period is equal to 2 pi and a half. P is a half, right? Flip it up. Huh? 4 pi. So this entire period took 4 pi. Right? But the question said between 0 and 2 pi. Right? So if here's 4 pi, here's 2 pi. Question said they only want the graph between 0 and 2 pi, so I don't want this part here. So I just had to rub it off. Right? I just leave it broken for some of you all to see the minimum value, right? But basically, this is the only part of the graph that you should have. Okay? So you complete this sketch will look like this. Right? When you finish that, what you have to do for now is write everything about cost graph that's it. And both of them one time. And then we look at it. Sketch it down. Huh? Okay, I'll have very time. Do the first. Right? Do everything and I did for you with the sine graph, sine theta for customer. You got this online? Ara? Yeah. Right. Okay, well, catch cost, do the same way. Cost is 0. Right, everything in all of cost, right? Okay. Right. So right before Matthew says it, I'm going to talk because
We're talking about
cost. Very cost.
well, you did the right question. We can't because yeah. Oh, very question. Is that new one are we doing that?
Right. So cos pi onto pi, 3 pi onto and 2 pi. Right? So the maximum value is 1, minimum value is -1. Cos 0 is 1. Cos pi on 2 is 0. Sine, sorry, cos pi is -1. Cos 3 pi on 2 is 0. Cos 2 pi is 1. So your graph looks something like this. Right? That is your cost graph. Okay? Max, min, same period, right? Same maximum value. Same minimum value. Same period. Right? Anybody recognize like what do I have to do to make the cost graph look like this sine graph? I'm gonna see if I remember all the transforms. How do I make the cost graph look like the sine graph? Yeah. How do I make this look like this or this look like that? Minus Minus 1 to bring it down.
+1.
Plus 1 to carry it up.
So you multiply by 1. By 2.
Quarter. Quarter theta.
Yeah.
We're playing it. So this is y is equal to sine theta. This is y is equal to cos theta. Yeah, so how I can make them equal? Cos,
So I just move it that way too.
so you put in, so y is equal to what? We'll make this look like that.
Yeah.
But it gets in there, it's close to it. So think about it, right? So basically, you're telling me to shift the graph, right? So shift the graph by pi on 4. So if I shift this graph this way, by pi on 4, it becomes that graph, right? How do I represent it? How do I write that here? So if I shift this graph this way, pi on 4, it becomes sine theta. Sorry. Did I write pi on? I write the wrong thing. It's not pi on 4. Sorry. Pi on 2. Sorry. So if I shift this graph pi on 2, it becomes if I shift this graph pi on 2, it becomes that. But where do I put it? If you remember your transformation. How do I shift something to the right on the x-axis? To the right is minus. You remember that? Oh, we don't remember, right? Yeah. But if you have for example f of x plus a, it will shift to the left. If you have f of x minus a, it will shift to the right. So if I shift this to the right, so it will be theta minus pi on 2, right? No, if you use double angle formula, you'll get it, right? That's not double angle, right? Right? So you would recognize that this and this is the same thing. Everybody okay with that? Right, so make a note of that, and then that's what I want. Oh wait, no. Before I do that, let me give it tan one time. Everybody okay with it? Online, are you okay with this? Chelsea, you okay with this relationship here? Yeah? All right. Oh wait, there's a good question for you, Javed. Javed, what is cos theta? Look at it there. I want to make cos theta from this graph. What to do? I'll give it the job.
Sin theta plus pi on 2.
Very good. Right? You move it to the left, pi on 2, it becomes down. So these two are the same. Okay? Two nice little rules to learn. Right, nice. Tan theta. Right, so we're going to try to sketch tan theta. It's a little bit harder than the others because there are some special values that you would recognize that we need to learn, right? Pi on 2 is one of them. Right, you'll recognize something special happens here. Something special happens here. Right? We'll take calculator and find tan phi on 2, and you will see something happening. error, right? So that doesn't exist. So your tan graph, right? So your tan graph, tan 0 is 0. Your tan graph looks like this. The values get bigger and bigger, but there is no answer for pi on 2. Pi on 2 is called your asymptote. Tan is negative between the second quadrant, positive in the third, and negative here again. So your tan graph looks like that. What do you think is the maximum value here? Just ask someone. No. Right? Maximum value is infinite. What's the minimum value? Negative infinity. Right? And last one. What do you think is the period of the graph? Huh? Right. What you say? Is this the whole graph? No. This is the whole graph. So it repeats itself every 180 degrees of pi. So its period is pi. Okay? Its period is pi. Right? Where is cos negative? Cos is negative in the second and the third. Where is cos positive? First and the fourth. Where is tan positive? First and the third. And tan is negative in the second and the fourth. Right? And that is where the all school teachers come from, right? All positive here, sign positive in the first quadrant, right? Tan positive here, cos positive. Right, copy it down. And I'll give you one to sketch. Come just again, you. Try that now. Try number 2, then I'll give you one more. So today we focus on the graph section, right? Then we started calculating the calculus next day. We started calculating. I'm going to find module 3 out.
What is the hardest? Questions about your team.
No, check that come ready.
No, buddy. No. I guess six. There's six behind us.
Check that some example really.
No, good.
Oh yeah. So this class, Kalina, can't believe that. So that's from Daria. Oh yeah. Try number 2, then I'll give you time to do.
I stay okay.
Why I keep doing 3, 5, and 2.
Yeah.
Then I'll break it up into 4 equal.
It's 2, 5, and 2. But look at that one there. I didn't share yet. It was so.
5 and 2. Then 2, 5, and 2. Then 3, 5, and 2. 2, 5, and 2 is the one.
You can see that? Not see that's okay, shut up.
Take and about the take or channel.
Yeah, buddy. Let's get it. Take the beats. No, come to the, 7th grade.
Ready? Well done. Take up your sponge on the board. I have to. You want to play it? All right, let me check it out. Right, so let me do a little thing here. We do a little thing here and here and here, and then that will become that. And then that will become that. All right. So that will become 1, 2, 3, 4, 5, 6. I'm doing anything here. Right. So let me start. Shift is -3. That's a new equilibrium line. So I'll join -3 here. I can pass. The maximum value is C plus amplitude, so that's 0. Minimum value is C -3, right? So the cost graph will look like this. I can pass. I can pass there, right? But we have a slight problem. The period is equal to 2 pi on 2, so the period is pi. And I asked for 2 pi. So 1 period is pi. Okay? But I asked for 0 to 2 pi.
Yes.
So I have to double up. Right? Since the period is pi, then I'll have two graphs, two cycles between 0 and 2 pi.
Yeah.
Are you okay with that? Are you sure? Yeah. So me, I'll get right. All right. Last one. Put Javin. Last one here. Put tan, right? Earlier, suppose I had this action, right? Suppose I had 3 minus 3 cos theta. What would happen?
3 minus 3 will be back. So we 3 plus
So the minus 3 will come.
theta plus 3
Right. So it's minus 3 cos theta plus 3, right? So therefore the shift is 3 upwards. What does that minus sign do?
Then the other side.
What does the minus sign do?
Oh, we got that.
What? It was supposed to-
You know the next side?
What next side means? What next side? Kalina. What that minus sign would do?
Next to right. Next back.
Huh?
The X, like the X axis.
Anybody want to have a guess? Huh? It will reflect, right? It will reflect. It will reflect in the x-axis, right? It will reflect.
Now I said.
Hang on. It will reflect in the x-axis, right? Last one. 2 times, sorry. Whenever it's minus, it's always reflecting there. Huh? Because all the positive now become negative. Look at the transformations for minus f of x. Right? Minus means all of this becomes underneath here, becomes negative, and all the negative will become positive. So the graph will look like that.
Oh, okay. Okay.
Right? Last one. Hurry up. Tan theta. Will the value in front affect the amplitude? Because infinity, right? Right, so that value in front wouldn't really affect the maximum value or the minimum. Right, Javin, hurry up. Last one here, Javin. Oh, wait, I forgot to give you the transparency measurement. Sorry. I forgot to give you the formula to find period. Right? So period is no longer 2 pi on 2 pi on B. Is pi on B. Right? So it's now pi on B, not 2 pi on B. So you got that one line. I forgot to give you what period will be, right? So here we know the shift is -2. Right? So that's the new equilibrium line. The max value doesn't change, the min value doesn't change. Period is pi over 2, right? So the period is pi on 2. Huh? All right, so what you see? This one might be a little bit harder for you to work it out, right? Okay. All right, ready? So here now, here we learn that the period is now pi on 2. When the period was pi, right? When the period was pi, here's pi, right? And here's half of pi. So if the period is now pi on 2, how much is here to here? Pi on 2, so how much is here? Right? Listen again for those who now tuning in there, right? Here to here, pi, right? In the original function, tan theta. Here to here, pi, right? So here to here is half pi, pi on 2, correct? That's when the period was pi. But now the period is pi on 2. So here to here will be how much? Pi on 2. So here will be pi on 4. So it will look like this, right? Here to here, this value is pi on 4. Here to here is pi on 2. So I have to write 3 pi on 4. Correct? Right? So it will look like this, like that. Everybody okay with that? Here to here is pi on 2, right? So add pi on 2 to this. Right? Here to here, I'm going to add pi on 2 again. Right? So that is that. Right? I'm going to add pi on 2 again. So that will be 5 pi on 4. Right? And then I will stop the graph here. Huh? No, the rubber piece. Yeah, this is the last thing. So pi on 4, 3 pi on 2, pi on 4, pi on 4, 5 pi on 4. Right? Are you okay with this? No, I let me go it over. Right? So the period is what? The period is pi on 2. The original period pi, right? So technically, and I should fit, and I should be able to fit 2 of this in this new one here. If the period is pi on 2, right? I should be able to fit, and the period here is what? Pi. I should be able to fit 2 of this, right? In this new range. Are you okay with that? So what I did for you is I just break it up. So the first part here is pi on 2. So it means that the first part, that's period 1, right? Quadrant 1, sorry, will be between 0 and pi on 4. Here was a whole pi, so it was pi on 2. Here is half pi, so here's pi on 4. And all I did is I just keep adding 2 pi. Adding 2 pi and got a quarter. Right? So add pi on 2 here, add pi on 2 here, add pi on 2 here. Right? And I just have a little quarter. Huh? Yeah, 8 pi on 4 is 2 pi. So I stop at yes. So I start at quarter pi, add pi on 2.
Yeah, but you see, add pi.
No, I said it wrong. Add pi on 2, add pi on 2, add pi on 2. That's okay? It's kind of a little bit harder, yeah? Right? Samira, you okay with that? You sure? Esther? Right? And I have to stop at 2 pi, right? That's why I stop here. Okay. So take your time and go straight, right, Esther? All right, last one.
What?
Whoa. All right, so we'll stop there.